Hi, I'm Bobby.
I'm Henry.
And this is our Trumpet Harmonizer, which is a way that a trumpet player can play in harmony with himself. And so the way it works is that we have a microphone which receives the output from the trumpet, and the audio goes through the USB microphone into the Raspberry Pi. And then in the Raspberry Pi, there's C code which processes the audio and pitch shifts it and then outputs it to the set of speakers. And the musician can can choose the amount that the sound is pitch shifted by pressing one of the values on this touch slider, which communicates through an Arduino to the Raspberry Pi using I2C.
And on the code side, on the Raspberry Pi, how we do this is through a library called Port Audio, which employs something called a stream, and the stream calls a callback function over and over where the audio is processed, and we use an FFT to get the highest frequency of the trumpet at any given time, so that we know what note is being played. Based off that, we shift the FFT and do a reverse FFT to go back to the time domain, and we use those values which we send back to the speakers so that the trumpet is effectively harmonized.
And one of the toughest parts of the project was writing the software for choosing the amount of pitch shift, because it depends both on the frequency that is being detected by the Fourier transform and the value that is being input by the touch slider. There are 6 possible values that the user can input. So we ended up just using a mapping from given a detected frequency and a touch slider input, what the amount that the Fourier transform should be shifted in the frequency domain is.
Now let's see an example of the trumpet being used.
So first, I'll show you how keeping the trumpet note the same, but changing the value in the pitch shifter changes the output to the speaker. And now I'll try to play part of the F major scale with a harmony that is the third above.